This is Math 112. We're going to be doing section 5.1, and we're doing number 3 here. Asking us to use finite approximations to estimate area, and we're going to be using two lower sums with 2 and 4 rectangles and 2 upper sums. So let's start off with part A, and these are going to get really similar quickly. There's 2 lower sums of 2 rectangles of equal width. So we're using the lower sum, and here I mean the lower as in the lower value, so not left hand sum. We'll get this rectangle right here, this rectangle right here, right? We want 2 rectangles to equal sum, and to check it, you can see that delta x is going to equal 5 minus 1 divided by 2, which is 4 divided by 2, which is equal to 2. That's what our delta x is. So the lower sum in this case is going to be so what the book has written down times the width. So our first xi is going to be at 3, and the second xi is going to be at 5. So we really just get 1/3 plus 1/5 times 2, which is, we do the common denominator here, we're at 5 plus 3 all over 15. It's 8 over 15 times 2 is 16 all over 15. So the area is just slightly above 1. Okay. Let's do another one. Let's do part B. We're going to get new rectangles. So let's erase these rectangles we got now. Part B says lower sum 4 rectangles. So we get this, 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 and this. Okay, so you're going to see that delta x obviously is 1 in this case. So they're going to get, let's ignore the summation notation. Here's how that works. You have 1/2 plus 1/3 plus 1/4 plus 1/5 multiplied by 2. Common denominator in this case would be something over 60. What a shortcut for you, something you can do on your calculator, right? 77 over 60. Again, over 1. So these two agree, not the greatest, but decently. Let's do upper sums, rectangles of same width, of 2 rectangles of same width. Okay. In this case, we're going to have upper sum here, and then upper sum here. Delta x is equal to 2, and we get 1 plus 1/3, giving us 4/3 times 2. Sorry, this is multiplied by 2. Oh, this is multiplied by 1 over here, so you don't need to worry about it. We're going to get 8 over 3. So in this case, it's greater than 2, where these used to be just barely over 1. So you see how big a difference taking upper sum and lower sum does. And finally, let's do part D. We're taking upper sum with 4 rectangles, so it will look like this. Pretty similar to the lower sum with 4 rectangles, but shifted 1 to the left. Delta x is equal to 1, so we don't need to worry about any multiplication. We get 1 plus 1/2 plus 1/3 plus 1/4. And I'll shortcut the addition there for you. It becomes 25 all over 12, just barely over 2. So if you see, if we arrange this in terms of from size, we get that here's A, barely over 1, and then next we get B, then we get D, and we get C. So you'll notice that the larger rectangles of the upper and the lower sums provide the widest difference, and then the multiple